Welcome back. Today we start our series into design a chat system. Today we start in the second step. We start in the propose a high level design. I guess this step will take. I guess it will take maybe like 3 or 4 videos. I'm not so sure. Let me check how many videos it will take. This one, two. I guess. Oh no. I guess 4 videos more. I guess 4 videos because we have a lot of steps that we have to cover in this in that second step, the proposal high level design. Today, before I said what I was going to talk today, in this series we have a series of videos that will talk about how to design a chat system into system design interview. In the previous video, we talked about how to understand the problem and how we establish the scope design. If you didn't watch it, I highly recommend you to watch it before you go to this video. So today we start our first video in the proposal high level design. We will talk about the polling and long polling and web socket. This is what we're going to talk about mainly. A minute, I typed web socket. Yeah, that's it. Okay, so we talk about these three stuff today. So before we talk about them, to develop a high quality design, we should have a based knowledge of how clients and servers communicate in the chat system. Clients can either be mobile application or web applications. Clients do not communicate directly with each other. Instead, each client connects to a chat service which supports all the features mentioned. So let's just take an example of that. So let's say that we have, let's take this and yeah, let's make it white. And the text also should be white, and I'll say this is client, and let's make it quite wide, and the client will connect with a chat service. Let's make it wider, and the chat service has two main job. It's first one, it's to store the messages, and two is to relay the messages. Okay, so let's just make it higher also, and why not make it even wider? Anyway, let's make it just smaller so we can yeah, I guess this one is way more better. Okay, also we will have the receiver, but just make it smaller. Wait a minute, it wants to okay, receiver, and yeah, just make this one a receiver. Okay, so as you can see here, when a client intends to start a chat, it connects with the chat service using one or more network protocols. And we'll talk about what is more network protocols, but just give me a minute. For chat service, the choice of network protocols is important. So let's discuss this matter. Requests are intentionally initiated by the client. For most client server applications, this also true for the sender. The sender, which will be the client, let's call this one a sender. So for the sender, we have we use the client server. We use a normal HTTP protocol. So what is an HTTP protocol? HTTP protocol, it's a hypertext transfer protocol. The purpose of the HTTP is it's in an application layer protocol used for transferring hypertext, maybe text with embedded links, things like that, and other data between clients, web browsers, and servers. And it's stateless. It has methods. It has headers. It has status code like 20404. It's the connection use the HTTP, typically use the TCP. It uses a TCP as its underlying transport protocol. So what is a TCP? A TCP, it's for a transmission control protocol. Is one of the main protocols in the internet protocol suited basically for TCP and IP addresses, and is used to establish and manage connections between devices over a network. TCP ensures reliable and ordered delivery of data packets between devices, making making a fundamentals protocol for many applications. So now you know what both of these terms means. So as I said before, requests are initiated by the client. As you can see, the requests are initiated by the client for most client server application. This is also be true for the sender side of the application, as you can see here in this graph, or this draw, if you can call it a draw. Why this is not white? Because if it's white, I guess it will be way more easy to be understood. Yeah, this is better. So when the sender sends a message to the receiver via chat service, it uses the time-tested HTTP protocol that we talked about, which is most common web protocol. In this scenario, the client opens an HTTP connection with the client open HTTP connection with the chat service and sends the message, informing the service to use the message to receive to the receiver. So the client open it connects with the server using an HTTP protocol, informing the service to send the message to the receiver. The keep alive is efficient. There's something called keep alive, and give me a minute. So if so the keep alive is featured in hypertext transfer protocol in HTTP that allows the persistent connection between a client, usually a web browser, and a server or service, enabling multiple requests and responses to be exchanged over a single connection. Without keep alive, a new connection would need to be established for every HTTP request and response pair, which can lead to increased latency and overhead. Okay, so this is what is keep alive and what is important for. So the keep alive is efficient for this because the keep alive header allows a client to maintain a persistent connection with the chat service. It also reduces the number of TCP handshakes. Let's say again, if you don't know what is a TCP handshakes, in this series I assume that you don't know anything. So I'm just trying to say everything. So if you know, that's good. If you don't know it, you learn new things here. So the TCP, it's more for transmission control protocol, uses a three-way handshake process to establish a connection between two devices, typically a client and a server, before any data transmission can occur. This handshake ensures that both devices are ready to send and receive data, and they agree on certain parameters for communication. So the handshakes have three steps. Step one, synchronize, and the client, also known as the initiating device, sends a TCP packet with SYN synchronize flag set to the server. This packet is used to request a connection establishment and includes a sequence number. It's called SYN sequence number, or synchronous sequence number, that the server will use to acknowledge the request. Step two, synchronize and acknowledgement. Upon receiving the SYN packet, the server responds with a TCP packet that has both SYN and ACK acknowledged flag set. The server also includes acknowledgement number that is one greater than the client's sequence number from the SYN packet. And finally, we have the acknowledgement, and this is finally the client response with an ACK packet confirming that has receiving the server SYN ACK packet. It looks a lot, but I just to be I will put everything in the description. So however, I guess however, right now the receiver side is a bit more complicated. Like, as a sender, the sender will connect with a chat service, which with HTTP, and the keep alive will make sure the connection is stable, and we use the TCP handshakes to reduce the we're using the keep alive to reduce the number of TCP handshakes, to make sure that we make the connection is more. We don't need to make each time a TCP handshake to make sure that there's acknowledgement between two servers. So it's pretty straightforward. We're building HTTP request, the sender sends a message to the chat service. However, it's a little bit tricky when we deal with the receiver. So the receiver side is a bit more complicated, since HTTP is client initiated. It's not retriever to send messages from the server over from the server. We can't send the messages from the server to the receiver, because the HTTP request is something that it's client initiated. The client should ask for the message. So we have three things to solve this problem. We have a polling and long polling, and something called a WebSocket. So let's start first talk about what is a polling. Oh, this is too big. Make it, yeah. So a polling, let's say that we have, can we make this way more smaller? I want to, and just, yeah. Let's say that I have client. Yep. And can I make it bigger? Yeah. Yeah, 14 is big. And I have, can I copy this one? I said that I have the receiver. Let's say I have the receiver. I wanna know if there's a new message or not, and I have the server. Receiver. I guess there's something I typed wrong with the receiver. Yeah. Oh. Anyway, so first of all, there is something called polling, and in polling, what will happen that let's just take a line. I want to take a line here and just put it like that. I don't want to have. I just want to have to be a straight line. Can I make it a straight line? Not just a line. Oh no, it should be an arrow. How can I have a line? I do not remember how to have a line. Okay, so let's just say that we have the server and we have the receiver. Okay, so the client in the polling, polling is a technique that the client predictably asks the server if there are messages available. Depending on polling frequency, polling could be costly. But how that happens, the receiver will ask, I have, oh, so this was too much. Will ask, do I have a new message? The server will say no. Okay, do I have a new message? No. Do I have a new message? No. Do I have a new message? No. Lost. Do I have a new message? Yes. So if you can see that it takes us like, I guess, 5 requests to get only one message. And this will read that we are wasting a lot of resources. It could consume like a precious server resources to answer a question that offers no as an answer most of the time, as you can see. There's something is better than it, something called long polling. And what happens in the long polling? In the long polling, a client holds the connection open until there are an actual new messages available in or a timeout has been reached. So, for example, let's just go back. The receiver will say, "Do I have a new message?" And wait, like no. So let's wait for a amount, and it will say no. So I will and it will say no. So I will ask after maybe like 1 minute, "Do I have a new message?" And I wait, no, and I'll ask lastly, "Do I have a new message?" Yes. So I will take it. So it's a better than just the polling, because it's that we are not wasting a lot of resources as we are wasting as in just polling. However, once the client however, the problems that comes with this solution is that senders and receiver may not connect to the same chat server HTTPS service. And the second thing, sorry. First thing, the sender and the receiver may not be connected to the same chat server. So the HTTPS servers are usually stateless. If you use, what is a stateless? If someone just asks what is a stateless, so the stateless, it refers to a design principle in computing where a system or application is designed in such a way that it doesn't retain any knowledge of past interaction or maintain any context about the current state of the client. In a stateless system, each interaction is treated as independent and self-contained without any reliance on previous interactions. This concept is particularly important in network protocols, web application, and distributed system. It's good. It's good at scalability, security, reliability of the application, and a lot of other things more. But it's not. It's not um, the the main thing to talk about this video. We can do this about this one in future videos. So if you use, for example, HTTP-based servers are usually stateless, okay, and we talk about what are stateless. So if we use, for example, round robin for load balancing, so the round robin is a simple load balancing algorithm that used in networking and distributed system to distribute incoming requests or tasks evenly among a group of resources. It's designed to ensure that each resource is given an equal share of the workload over time. So if you are using the round robin for the load balancing, the server that receives the message might not have a long polling connection with the client who received the messages. So maybe you are connecting with different server each time. So this was like lead to nothing but disaster in the not disaster, but just it will be pretty hard to deal with this specific thing. We have the second thing: a server has no good way to tell if a client is disconnected. Also, it's inefficient. If a user does not chat much, long polling still makes a periodic connection after timeouts. So we know that polling and long polling are not that good. What is the good one? The good one is to use WebSocket. So web sorry, yeah, web socket. What is a WebSocket? Let me delete this too. No, let keep them. Let me keep them. Let me delete this and this and this. So in the WebSocket, connection is initiated by the client. It's a bidirectional and persist. It starts its life as an HTTP connection and could be upgraded via some well-defined handshake to a WebSocket connection. Through this persistent connection, a server could send updates to a client. WebSocket connection generally work even if a firewall is in place. This is because they use port 80 or 443, which are also used by HTTP and HTTPS connection. So let's just try to talk what's happening. So the WebSocket is bidirectional. So basically, when the receiver doesn't need, first the receiver connect with the server with a handshake, and after that, whenever the server will send back the acknowledgement that we are being connected with the receiver. So when the connection is done, we have a bidirectional messaging. So for example, the server, whenever the server finds there's a new message for the receiver, it will send it directly back to the receiver directly and doesn't need to wait for anything. And the other thing that we talk about the WebSocket connection generally work even if a firewall is in place. Firewall. Sorry. So what is a firewall basically? A firewall is a network security device or software that acts as a barrier between a trusted internet network and untrusted external networks, such as the internet. Its primary purpose is to control and monitor incoming and outgoing network traffic, allowing authorized traffic to pass through while blocking unauthorized or potentially harmful traffic. Firewalls play a crucial role in protecting networks and systems from various types of cyber threats. So, what is the port 80 and port 443? And basically, port 80 and port 443 are two most commonly used port numbers in networking, and they have specific rule related to web communication and internet security. They are both part of the Internet Protocol suite, the TCP, and are frequently used for communication between web clients and web server. The 80 port is the hypertext transfer, and the 443 it's used by the HTTPS. And the hypertext transfer I talked to about it, the HTTPS, it's the same thing, but it has secure, so it has more security than the HTTP. So this is it. But let's just talk about in details about how the WebSocket work. So let me just before we said that on the sender side, HTTP is a fine protocol to use, but since a WebSocket is bidirectional, there is no strong technical reason not to use it also for sending. So let's just create something to talk about how this will work. So we have no, I don't want to have this one. No, no, let me have this one. Yeah, so let's say that I have sender, and the sender will connect with a chat service, with a WebSocket and the chat, and also we will have another one. Let's put it here, which will be, let's call it receiver. It will connect receiver. Sorry, I all the time do it like that. And the receiver also will connect with the chat server using sorry. Okay, using also a WebSocket. So by using WebSocket for both sending and receiving, it simplifies the design and makes implementation on both client and server more straightforward. Since WebSocket connections are persistent, efficient connection management is critical to the server side. So the receiver, the sender, will establish a WebSocket connection with the chat, so with the chat service, and also the sender and the receiver will do the same thing. So the server, when the server sends a message to the chat service have a message to the receiver, it will send it directly. And when the receiver sends a message to the chat service and the chat service find there is a message for the receiver, it will send it directly, because the WebSocket is bi-directional connection protocol. So the WebSocket is a communication protocol that provide full duplex bi-directional communication, as you can see, over a single one. It's called long-lived. It has a long-lived TCP connection. It allows for real-time interactive communication between a client, usually a web browser or a mobile, and a server. Okay, WebSocket overcomes the limitation of traditional HTTP HTTP connections. We use HTTP, but it's slightly different, which are typically request response based and stateless. So I guess it was a quite long video. I guess maybe you have like maybe 1 and 2, yeah, and 3 and 4. Oh, we have 5. We have 5. We have 5 in this in this second step only. It will be, because it will be a lot of information, because actually building a chat system, it's not easy. Why it's not yeah, okay. So I guess this step will take a lot of time. The deep dive, I guess, will not be that much though. Let me check. I guess the deep dive, yeah, the deep dive. Oh shit, the deep dive has a lot of things. Oh, the deep dive will be like only 6 or 7. I guess to be 7 videos by itself. Anyway, we have nothing to do. We have nothing to worry about. Sorry, we have nothing to worry about. We'll just to go step by step, and after that we will reach our goal. So that's it for this video. I hope my description was quite good. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video. And see you in future problems.